For today's video, we're going to be looking at an offline or open source agentic solution that can control your computer using natural language, which, to be honest with you, is actually a little creepy to experiment with for the first time. This is called UI-TARS, or TARS as I will probably refer to it, and it is made by Bytedance, who you may be more familiar with as TikTok's parent company. So to have something like this that is essentially almost a kind of locally hostable version of OpenAI's orchestrator is very interesting. And I am going to jump right into an example right now because I do have to say, in playing with this for a little bit of time, I am rather enamored with its performance. So I'm having it search the web for Ominous Industries, which is my name of my robot. And we can see that it just totally took control of my computer. It does seem to be having a bit of a issue actually getting stuck on the tab, but it did it very quickly, and then it says action finished. So this really is rather impressive for something that does not require a subscription fee, an expensive subscription fee, and can actually be locally hosted. So this is running through vLLM on the computer behind me right now, and I will do one more example. So I wanted to click on the tab for the GitHub over in the left so we can actually kind of take our first look at the repository. And we'll see how it does. And you can really see like it takes control. So it didn't necessarily click on the leftmost tab, but it got close enough and it did kind of see the GitHub thing about it. And we can see that in the actual prompt and like terminal output there in the UI TARS application window, it does have the thinking thing, which has obviously been all of the rage lately, is the kind of model's ability to show you a chain of thought or something like that. So I am going to stop this real quick as it does seem to be kind of a bit stuck, but this kind of gives us the look at what this is based off of, which is the Bytedance automated GUI interaction with native agents. And from here, we can see that this is basically a model that allows this to run and perform autonomous actions on your computer based in just kind of plain English prompting. Now, this is not actually the GitHub repository for the desktop application that we see right here. This one is, which is what I wanted it to click on, but it got close, so we'll give it that. And we can see UI-TARS desktop is a GUI agent application based on the UI-TARS vision language model, which is the GitHub page we were just on that it accidentally clicked on. And it allows you to control your computer using natural language. When this came out a couple of weeks ago, I actually did find out about it like a few hours after it came out, thanks to a Reddit post, and I went and played with it, and they did actually have a GGUF quantized model that you could use with Ollama with this. They unfortunately deleted that from Hugging Face because they said the performance wasn't up to par. I did test it and it really didn't do anything at all, so it wasn't very good, but I was kind of upset about that because it just kind of allowed very limited hardware to actually try to run this. So we will see right now that if I open the NVIDIA SMI right here, this is using the 2 billion parameter model, and it is taking up about 19 gigabytes of video RAM. So you can obviously imagine that the quantized version of the model would have been much more easy on the graphical hardware, if you will. And if we scroll down, we can see that this is cross-platform, so it is available for Mac OS, and they have a little quick start here for that, and also Windows. And for the model, we can see that there are three kind of main versions. So there's a 2 billion parameter model, a 7 billion parameter model, and then a 72 billion parameter model. What we just saw working in the introduction and previous points of this video leading up to now was the 2 billion parameter model. So basically one that is not even recommended by them, and it worked relatively well for what I would have expected. Now, before we get into kind of like how you actually get this set up and running and things like that, you may notice that I'm actually running this on Ubuntu, and they don't actually show that as supported here. So that is actually thanks to a very talented individual here who opened a pull request for Linux support. And if we click on here, there is the repository for the forked version of this that works with Linux. And thanks to this, it was really quite simple to actually get this up and running on Ubuntu with vLLM. We are now going to go through the steps to get UI TARS running on our local machine. Now, before we get into these steps, I do want to specify that I am using this with vLLM to run the model required for UI TARS on NVIDIA GPUs. If you do not have NVIDIA GPUs or are using some other way to run the model, I don't know that these steps will be very applicable to your specific use case. However, I do want to just show this as a lot of people interested in local AI at this point probably have some NVIDIA card or something like that. So with that disclaimer out of the way, I have basically just prepared a little instruction set here, and I will also go ahead and paste these on GitHub as a GitHub gist, which you can just think of as like a sticky note. So you can easily kind of follow along with this on your own machine at home. With that said, let's just get right into it. The first thing we're going to do, and some of these commands do come from this GitHub repository for this forked version to allow it to run on Ubuntu. If we scroll down here, we can see there are some Linux specific instructions. So we are going to go ahead and just run these two commands here, which will go ahead and just kind of install some dependencies and things like that required to help this actually control our screen, if you will. The next thing, I like to use Conda, which just kind of can isolate different environments and perhaps prevent potential conflicts of like packages and dependencies and things like that. So we are going to make a new Conda environment. I am just calling it GUI and using Python 3.10. And the Y is appended at the end there to just automatically select yes when it asks if I want to install all of these packages. Once that's done, we are going to activate the environment by just typing conda activate and then environment name. And I will be clearing a lot here just so the old text doesn't kind of clog up our viewport so we can see kind of what's going on in the terminal. The next thing is going to be to install PyAutoGUI, and you may see that in the actual repository here for UI-TARS from Bytedance, they mention that it is a GUI agent application. So think of this as just graphical user interface, which is what GUI means, but this is just another dependency that kind of allows this application to control our screen and interact with it and things of that sort. Once that is out of the way, if you were installing it for the first time, you may see slightly different terminal output than what I saw, just because it was already cached on my system. So for yours, it may show slightly different, but that is the command to install it. The next thing we're going to do is install Node.js. Now, for kind of the next few steps, basically like here to here in this instruction, I'm just going to give a general overview. These are essentially to kind of allow this application to just be built and run on our system, so without getting too complex. However, if we were to just do a standard Node.js installation here, we may encounter an issue, which I actually did. So I just did like apt install Node.js, and unfortunately it installed an older version. But as we can see here in the actual repository, we need greater than or equal to version 20. So all I did for that is just go into some of the GitHub stuff for installing Node.js, and there were a few different commands we needed to actually kind of compile and do to actually install that specific version. I do just have these all listed here, but that is just to give a little bit of background info for why we're doing it this way. So we are just going to run this first and foremost, and we will see, okay, mine is already the newest version, so. But if you were doing it for the first time, it will go ahead and, of course, install it. We are then going to install or download this specific version installer, and you won't get any like output when you do that, so don't get confused and think like, did this not work? It's just kind of the nature of how that goes. The next thing we're going to do is run this little setup script, which we will do right here, and we will see that it will go ahead and kind of do its thing. And then following that, to actually install the specific version of Node.js, which is greater than or equal to version 20, and we're doing version 20 here, we will just run this. Once that's done, is it Node-version? We will see that we have greater than version 20, so we will be all set with that dependency to actually be able to run UI-TARS. Following that, we are just going to run this, which we can just kind of again think of as just something that will help us run and build this application on our local system. Oh, and we can see that we got a permission error, which of course means that I did not run that command with elevated permissions. So all we do to fix that is just append sudo to the beginning of this command, and then we can once again go ahead and run it, and then it should go, and we can see it did work. And finally, we're now at the point where we can actually clone the GitHub repository to our local machine, which gets us one step closer to actually playing with this, which is of course very exciting. So we will do that and see that it has cloned it into this folder of UI-TARS-desktop, and if we go into our file browser, we will see that folder does now exist. And the following command there just changes our working directory into that clone folder. The next step is to actually go ahead and just kind of think of this as like installing this as an application on our computer. So we will run this, and it will go ahead and actually install the UI-TARS application onto our system, and we'll see some things there. Fortunately, this happened pretty quickly. And then to actually run this from within the UI-TARS desktop directory, we can actually just click this, and the application will open and run on our machine, assuming everything has gone all right, which fortunately it has. Now, this is one step down. However, the other step to this is actually hooking this up to the AI model that will allow us to actually run this. And for that, we're going to be using vLLM. So these subsequent commands actually kind of handle that section of this. So all I'm going to do is just X out of this, and then from within the terminal here, I am going to just Control C, which will kind of just think of it as like pressing X there on the application, except it does that for like what's running in the terminal. Now, there are two ways to go here. We could just install vLLM in this Conda environment as well and run it. However, I don't really like that as a solution. So I think I am just going to make a new Conda environment for vLLM and then set it up in that environment separately. So to do that, I'm just going to open a new terminal window by holding Control-Alt-T, and we can see we get a new terminal window here that is not in any Conda environment, as we can see by the base here, as opposed to the GUI environment we had made. And I will just basically create a new Conda environment. So Conda create, and I suppose I'll call it vLM, not vLLM, but vLM. Whatever you want to call it is totally fine. And then Python version, so I'll use 3.10, and then I will do -y, and it will go ahead and, okay, so, oh, whoops. So you have to do conda create -n and then environment name, and then that will go ahead and do it. So I will now then conda activate vLM, and we're in. So the next thing we're going to do from this environment is basically install vLLM. Now, to quickly give a little more information, the part that I am referencing here is not actually from the UI-TARS desktop application repository, but actually, since I can close out of this, from the UI-TARS model repository. So if we scroll down here, we will see a little bit about running these models using vLLM. You have to scroll down pretty far. And the command we're going to run comes from right here in this repository. So just kind of keep that in mind, that this is coming from the UI-TARS repository and not the desktop one. I suppose I just wanted to say that, like, so if you're curious, okay, well, where do you get this command from? Like, how do you know this is what you need to run? I just wanted to kind of show that, I suppose. Now, before we do this, there is one thing to check. So if we type NVIDIA-SMI, it will show us information about our NVIDIA graphics cards. And this is going to just kind of already have assuming that you have the driver installed on your Ubuntu system to actually be able to communicate with the cards, which you very likely do if you have your system set up at all. Now, this version right here for CUDA version where it says CU124, this 124 needs to match what you see when you run NVIDIA SMI, and it says CUDA version 12.4 right here. So if you don't see 12.4 in your NVIDIA SMI, you will need to adjust this to reflect the version of CUDA that you see right here. And without actually having a different CUDA version to test that, I can't guarantee that would work, but I do just want to show that just so you have a starting point if you have a different CUDA version. And with that out of the way, we can then basically just go ahead and run this command all at once. And it may take a little bit of time, so we just press enter and it will kind of go ahead and do its thing. All right, and we can see that after a little bit of time that will have completed. And I'm just going to clear it because there was a lot of slop in the terminal left over there. The next thing we're going to do is basically run vLLM with the model. Now, here comes a little bit of personal preference, and by personal preference, I mean depending on what video card / cards you have available to you. So if we scroll down here and remember that for the vLLM stuff, most of this instruction comes just from the UI TARS repository as opposed to the UI TARS desktop repository. If we scroll down here, we will see that there are a few different versions of the model. If we keep scrolling down, there's a 2B SFT, a 7B SFT, a 7B DPO, and a 72B. But to make it simple, there's a 2B, a 7B, and a 72B. Now, the 2B SFT version here, you might think like, okay, it's a small 2 billion parameter model. It's not. It's using around 19 gigabytes of video RAM to actually be run on my system. So these are pretty heavy duty. And the reason I bring this up is just so don't think like, oh, I can run Llama 3 8B, so I'm just going to download the 7B. It's not the same. So my suggestion and what we're going to do here is just begin with the 2B. Now, again, to actually understand where some of these commands I have here are coming from, the next thing we will run is this, which will essentially serve the model through vLLM. However, we need to actually download the model since we don't already have it on our system. And to do that, we do see that this is actually the same command as I just showed you. It's just in 2 lines instead of 1, 2, 3, 4. So don't get confused by that. So path to your model is going to correspond to the actual, if we click on one of these, Hugging Face path where the model is hosted. So since we are using this 2 billion parameter version of the model, we would just copy everything that came after the / here for huggingface.co, and that would be the model we were going to download. If we were going to click this 7B DPO one, we would then just copy this and paste it into the command. However, to begin, we are just going to use the 2 billion parameter model. So this command as it sits will work for our purpose. And if we go ahead and run this, it will begin to download the model because it is not already on our system. And we can kind of see that'll happen here. It's not too big, but it's, I mean, I think it was like 2 4 gig files, maybe. Yeah, okay, so it's 2 5 gigabyte files, not including like all the other associated things, which are not very big. So this will take a little bit of time to download depending on your network speed, but once this is done, we will basically be able to actually go ahead and get our first look at using the UI TARS application on our system. So once it completes downloading, we will see it kind of just giving us a URL right here. But for the purpose of what we need, this is actually pretty much all we needed to do with vLLM, because this will actually download the model and start running it. The next thing to do is go back into the other Conda environment or wherever you were running the actual UI-TARS application. And from within the desktop folder or the directory of where you cloned it into your system, so for us is right here at home / username / UI-TARS desktop. So we can basically just do pnpm run dev right here. And this time we won't see anything different, but because we have the model running now, we can go ahead and actually enter in the information to get this to work with the vLLM instance we have running. So we click the settings button right here, and in here you see that there are a few things which can be a little confusing, but fortunately I figured out how to get them to work without needing to do too much. So for the URL, we are just going to copy this and paste this in for the base URL. For the API key, I've just been typing empty because somewhere here it just said that, so I'm just doing it exactly as it says to do here. And following this, we are going to type the vLLM model name, which we can see here based on the command to actually run with vLLM is just UI-TARS. So we will just enter that in right here. And once we do that, we will click save. and the settings will save, so we can close out of the settings window. And then from here, hopefully, if everything has gone well, we can basically tell it to do something, and it should then go ahead and actually take control of our system and do it. All right, and we can see that it is thinking. And okay, so it didn't quite get it, but again, this is the smallest model, so it did seem a little confused, and tried to close its own terminal. Okay, so we're going to cancel that. But really, that is how you get it running, and that is how you install it and get it running. So let's just try running it one more time and seeing if we can make it a little more functional. So we can just start it again by from within the clone GitHub repository folder running pnpm run dev, and that will go ahead and open the application here. Let me minimize this. Let me maximize the browser and go back into this. And the settings should be saved, so you just want to check to make sure, but I think they do persist across sessions. But if you do have any problems with it, that is definitely one of the first things to check and make sure is all right. So we can then again, let's just open a new tab. And then we'll see. Perfect. So that worked completely accurately and fantastically. And then we can see, fortunately, the action did complete successfully. And you can kind of read some of its output here. So, okay, I need to click the plus button located at the top, blah, blah, blah. And you can actually see the screenshots that it captures in order to kind of give itself a viewport of your system. So this really is quite cool. So that's basically going to conclude this video. It is currently trying to play chess. Fortunately, it is not really doing a fantastic job of it. It doesn't seem to understand that we are the black chess pieces. However, I did want to just kind of show this off because I do have to say it is really quite cool and impressive. I really wish I had the compute capability to try the 7 billion or 72 billion parameter model for this, as it definitely shows a lot of potential, especially for something that can be run locally with local hosted models. So the only other thing I want to touch upon, okay, this is so weird. Like I'm trying to control the mouse and then it just drags away. It's very weird and off-putting. You may be wondering, because this is using vLLM, is it possible to actually split the model across multiple GPUs so that you don't end up using the entire 19 gigabytes that this 2 billion parameter model is using on one card, but over across two instead? Unfortunately, due to the architecture of what this is based on, so if we go into the GitHub repository here, we can see that it is built upon the capabilities of Qwen 2 VL. Now, don't quote me on this, but from my understanding, some of the architectural things about these vision language models make it so that you can't just split it across two cards like you would be able to if you were running like Llama 3 through Ollama or something. So I actually did go about trying this just because I wanted to be sure. You can kind of see in some of the vLLM docs, they have distributed inference, which talks about running on multiple GPUs or across multiple computers with multiple GPUs. And unfortunately, the result of changing this TP here, which is tensor parallel, as we can see right here. So if we changed it to 2, it would say run it on 2 cards. Unfortunately, that just kind of ends up duplicating the model across both cards. So instead of one of them using 19 gigabytes, they both end up using 19 gigabytes of VRAM. So I just did want to point that out, as if you have like a dual 3060 12 gig system or something. Unfortunately, I think you may have to just wait for the Ollama GGUF of these models to be fixed and then hopefully put back out there. That is really going to conclude this. This is very fun to play with and very cool, and I just wanted to do a video on it as I'm quite impressed with it, especially after playing with ChatGPT Operator. This is almost like you know the meme, like we have Operator at home, and like you would show this. So, all right. Thanks for watching. If you have any questions, please leave them in the comments, and I will post the instructions that I followed here on GitHub as a GitHub gist, and I will just place them in the pinned comments for this video, as I generally do when we do like instructional things. All right. Thanks for watching.